we need to divide by that number first. So if you have a 3x squared, you're going to have to divide everything by 3 before you start. Then we move the constant to the other side, and then we're going to go through these steps to create a perfect square. So let's kind of step through a problem and try this. Now, completing the square would probably never be your first pick. We would try first to see, does this factor nicely? So we're looking, is there anything that would multiply to negative 14 and add to negative 4? No. So if we can't do those things, then completing the square becomes an option. And it will always work. So it's not like sometimes it will, sometimes it won't. It will work. We just have to rewrite the problem to match a correct form. So we need a 1x squared, and we've got it. So second step, you move the constant to the other side. And I'm just going to leave a little space here. Oops, and that would equal a positive 14 when you add it over. Now, we are trying to create something that factors nicely. So we are going to make a perfect square. To do that, think about a perfect square. If I said x squared minus 6x plus 9, what does that factor into? So x minus 3 squared. If I said x squared plus 10x plus 25, what does that factor into? If I said x squared minus 24x plus 144, what does that factor into? Okay, these are perfect squares. So if you look at the pattern, if I took this middle term, how can I look at that 24 and know what my constant has to be? We can divide this by 2. 24 divided by 2 is 12. And then what do you do to 12 to get 144? Take to the second power, yeah. So 10 divided by 2 is 5. 5 squared is 25. 6 divided by 2 is 3. 3 squared is 9. So to make this perfect square, we're going to take the middle term, we're going to divide it by 2 and square it. So that's what, when you look at the process, square half coefficient of x and add it to both sides. That's what we're doing. So when I take negative 4 as my term, I need to divide that by 2 and square it. So what's negative 4 divided by 2? And negative 2 squared? It's an equation. Whatever you do to one side, you have to do to the other. So I add 4 to both sides. Now, this should factor into a perfect square. What multiplies to 4 and adds to negative 4? Negative 2 and negative 2, or x minus 2 squared. You'll notice negative 4 divided by 2 was negative 2. Whatever you had before you squared is the number that's going to go here when we factor. Now this is something we can solve. How do we get rid of a square? And if you add a square root in a problem, we also need x minus 2 equals plus or minus. Alright, I need to break down 18, so I can take 9 and 2. So square root of 9 is 3. Radical 2. Final step, add over my 2. So I get 2 plus or minus 3 radical 2. Typically, the answers are going to be kind of ugly. They'll either have a radical or an I in them. If they don't, that just means that it probably was something you could have factored nicely to begin with. But this would still get us an answer. All right, let's try some more. Notice anything about this? Greatest common factor. What could we take out? A 3. We can either pull it out just in front, or we could divide by it on both sides and get rid of it since it's an equation. What do you guys want to do? Factor it out or divide? Okay. Alright. So if I look at this point, does 3 ever equal 0? No. So we really need to know when this inside part equals 0, right? If you try it slip inside, is there anything that multiplies to 9 and adds to -4? No. So we have to complete the square. Because it is not a 1x squared, what's the first step for completing the square? Divide. So I have to divide everything on both sides by 3. So we get x squared minus, I'm just going to keep this as 4 over 3x plus 1 equals 0. Alright. Completing the square. It says we move the constant to the other side. We take the middle term, which was -4/3, divide that by 2, and square it. What is -4/3 divided by 2? Alright, if I square that, -2 squared, +4, 3 squared is 9. If you add it to one side, you also have to add it to the other. So now, this should factor into something squared. Might be a little bit harder for you to figure out that number with the fractions, but it's always going to be what we had before we squared. So this will be x minus 2/3 squared equals -1 plus 4/9. So -1, that's like -9 over 9 plus 4 over 9. So -5. Okay, how do we get rid of a square? And with that, we always do plus and minus. So x minus 2/3 equals plus and minus the square root of -5. So that would be I radical 5. Square root of 9, 3. So then final step to get x by itself is to add that 2/3 over. So be 2/3 plus and minus I radical 5 over 3. I know that one was a little bit uglier. Do you have questions? Are you ready to try one on your own? Worry about that. Add over the 2 because it doesn't factor nicely. So you take the middle term divided by 2 and square. So -1 squared is +1. Multiply to 1 and add to -2, that's -1 and -1, just like we had the -1 here. So it's x minus 1 squared equals 3. Square root plus and minus. Add over the 1, so we have 1 plus and minus radical 3. If you ever solve this and get to the point where it's like 2 plus or minus 5, I don't want you to leave your answer like that. What is 2 plus 5? And 2 minus 5? So if by chance you get a nice answer, go ahead and work it out and tell me what the two numbers are. Okay, do we need to do another one like these? What about one where we have a coefficient? Do we need to try one more like that? Let's say this one. So first step, we need the a term to be 1. So we have to divide everything by -4. So we get x squared minus 2x equals -7/4. Second step is to move the constant over to the other side, but it's already by itself, so I really don't need to do anything there. Next step is to take the middle term, so -2, divide that by 2, and square it. So -2 divided by 2 is -1. -1 squared is 1. So I'll add 1. So what does x squared minus 2x plus 1 factor into? Square. Over here, -7/4 plus 1. Now square root plus or minus, so x minus 1 equals plus or minus. Square root of -3 would be I radical 3. Square root of 4 is 2. So our final answer is 1 plus or minus I radical 3 over 2. Alright. Is that okay? What is the other option that will work to solve any quadratic equation I might give you? Quadratic formula. Okay, so quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let's say I gave you this one. So in the quadratic formula, we do need everything to be on the same side before we could solve it. Really, even if we just wanted to check if we could factor, we need everything on the same side. We have x squared minus 4x plus 2 equals 0. Alright. Is there anything that multiplies to 2 and adds to -4? No. So we could do completing the square if we wanted to, or we could do quadratic formula. So x equals the opposite of b. So remember, a is the coefficient on x squared, b is the coefficient of x, and c is your constant. So my a will be a 1, b is 4, and C is 2. Opposite of B would be a positive 4 plus or minus the square root of B squared minus 4AC all over 2A. In here, I don't want decimal answers hardly ever. We're just always going to keep things in radical form in lowest terms. So if I work this out, 4 squared is 16 minus 8, so that would be 8. We could break 8 up into a 4 and a 2. So that would be 2 radical 2. And then final step, we could divide all of those by 2, so we get 2 plus or minus the square root of 2. Do we need another quadratic formula? Did you use that a lot last year? Are we pretty good with those? The last thing that I want to touch on today is the discriminant. Does anyone remember what the discriminant is?
It's like the square root thing.
Yep, it's the thing under the square root, b squared minus 4ac. So it doesn't include the square root itself, it's just everything underneath it. So the discriminant is used when we want to predict our solutions. So b squared minus 4ac. So maybe I don't really care about what the answers are. I just care about what kinds of numbers they will be. It impacts the graph. If you remember, solutions are where it hits the x-axis. So if something gets 2 solutions, it's hitting the x-axis twice. If we just get one answer, it hits the axis and bounces off. And what kind of, if it's imaginary answers, what does it look like when you graph it? Does it ever hit the x-axis if they're imaginaries? No. So the discriminant is useful in telling us that. So there's 3 cases. If your discriminant is greater than 0, that means I set up my quadratic formula and I have a positive number under the radical. Then that means we have plus that number and minus that number. So we get 2 real solutions. Or in terms of a graph, that means there are 2 x-intercepts. If your discriminant equals 0. So that means that we get something like 2 plus the square root of 0 and 2 minus the square root of 0. What's the square root of 0? 0. 2 plus 0 is 2. 2 minus 0 is 2. So we get 1 repeated real solution. In terms of our graph, that means it's 1 x-intercept. If it is less than 0, if you have the square root of -4, what kind of number do you get out? An I. And can we graph imaginaries? No. So what happens is we get 2 imaginary solutions. On the graph, that means there are no x-intercepts. do a couple examples of that, and then I'm done. So 5 wanted the number of real solutions to this equation. You could go through the whole process of solving it and then just tell me what you got at the end, but all we really need is the discriminant. B squared minus 4ac. What's the b value? My a, c, we get 25 minus 12, which is 13. So my discriminant is 13. That's a positive number, so what does that tell me? What am I going to have to do before I can find my discriminant on this?
Subtract.
We need everything on one side. So my discriminant, b squared minus 4ac. And then 1/4 squared minus 4 times 3/4 times 1/4. So we get 25 over 16. What does that tell me?
Two resolutions.
Positive number, that's all we care about. If it were a negative, what would we have said?
Two imaginary.
2 imaginary. And if we got 0, then it's just 1 real. Alright. Anything else that you want more practice or we need to go over here? So I posted a handout on Google Classroom. You've got about 20 minutes right now to work on that. It has a review of everything from this section.